Okay, so I'm going to take one of these linear UK power supplies and replace the guts of it with the readily available Meanwell power supply that everybody seems to like to use. I hear or read in the forums that people are using these all the time, and I don't really hear much in the way of complaints. You'd think somebody would have complained by now, because people have been using these for a few years. This latest model, now these power supplies are now becoming available readily without the cage. Previously, they all came with a cage, so this has the advantage of not having any issues of fitting into this case in any way, shape, or form, and leaving plenty of room to run wiring for the low and high side. It has a disadvantage of possibly not being as easy to mount, because with a cage on here, it's so tight that it's sort of, you just kind of wedge it in there and it just kind of stays put, from what I could tell. I've never done this before. This is my first. So this is the new Meanwell OEM packaging without the cage. And yeah, PT-65B. So everybody in the forum talks about getting these in the cage, and apparently now you can get them outside of the cage. And it's a little cheaper that way too. You don't have any connector here. I mean, it would be kind of convenient. I believe when there's a cage on here, all the connectors are present on one side. You know, all of the high voltage comes over and the low voltage comes over, and there's a big barrier strip on this side. You know, I guess I can think about how I want to do this. I can get these Molex connectors and just attach the wires to it and kind of make it plug and play. I have taken a few of these apart, and I think what I normally see is that I'm trying to remember if it's the high side that's on modulars or the low voltage side. You know what? Let's just take a look. Not modulars, but oh, that's too tight. But a Molex removable. What do you call it? Spade connectors. Spade connectors. Only one side has spade connectors on the one that I just recently looked at. So this is a linear one. That was a switch mode power supply that I was looking at. So let's just see. Maybe I'll have to pull that switch mode out again and check it. I don't think this one's been opened. Its screws are kind of sticking to the plastic at first. Yeah, that's right. Some of these older ones usually have longer screws too. The question is how am I going to mount that in there and make it secure? I don't just want to like hot snot it in or something like that. I don't want to stick it in with a bunch of zip ties or some sort of gap filling material. They're all loose. So just come on. There we go. Look at the size of that transformer. Wowzers. Okay. Yeah, this one is hardwired in on the high side. And oof. Hardwired in on the low side. So it really doesn't matter, man. Yeah, these things are a trip. Got a fuse, we got a fuse, so Yeah. Switch, so we'll just wire the switch and the high side up. Okay. And here we have my typical setup with the UV light and some tin foil to maybe help with reflection to get the sides. You know, I'm going to have to spin the thing around anyway. I made a separate video about retrobriting, so I'm just using that same technique, and we'll see how well it comes out. Okay, so here we have the cleaned up case, de-yellowed mostly. Looks pretty good. Here we have the Meanwell 65, and I have tried, it's very odd. I suppose the one that's in the cage may not have these connectors because I really can't see how it would have fit with the cage. I mean, it's only got to be bigger, and this one really doesn't fit. The only way, I've tried it this way, it's very close but not quite. I've tried it at an angle. The only way I could close the case without modifying anything was to put it push it all the way this way, bring this end down and this end up, and of course the low voltage side is going to come out of here, and the high voltage side and the switch, high voltage input and the switch is here. So we have the high voltage connector here, and this is the only way I could get it in there. And once I have the case on there, it wiggles around a little bit, you know. It's a little bit of clearance. So I still need to think about possibly cutting into this case a little bit. I'll tell you what I do have to cut into for sure is this piece right here. What I plan to do is to put one of these IEC power connectors in here. This would allow us to have a detachable cord, which the original never had. More so because this power supply goes from 90 volts input to 250 volts input. It would allow somebody to very easily just simply switch their respective PC power cord from their respective country and plug it in here, and that's all they have to do. They don't need an adapter, they just take a power cord and plug it in here, because this is a worldwide standard connector. And they won't have to do any switching of voltage or anything, because this thing has a very flexible input voltage. It's a global power supply, you might say. Okay, so we're going to go ahead and cut this back plate off here to give us room, and then we'll do some more test fitting. I'll be able to get this down inside and see actually how much room I have, but I can't do that until this thing's out of the way. get the bottom with the Dremel. Okay, should be good. All right. Yes, I need to remove more material, of course. I knew that was the case. A little more. Let's see what I'm doing. That's it right there. So I just need to try to get a straight line down to the bottom. It's close enough for now. I need to shave it a little more. Right, so I'm all the way down on the bottom with this wing. Geez, I'd almost rather cut the wings off and epoxy this thing in there. That sure would let me make it low profile and not have the wings outside. Now basically the technique that I'm going to use to decide is I'm going to shave little by little. I'll probably open up this hole and get it close and then reevaluate and reevaluate. Once I'm done evaluating, I'll come up with a plan in the end. Yeah, see, this is definitely going to stick up above the other case, the other top of the case, so yeah, I don't think those wings are going to help me anyway. I just don't think that's going to work too well. I mean, I guess you could, hypothetically, if you put these wings on the outside, you would have a screw going into this one on this piece of the case and another screw on the other side of the case, but I mean, you'd be surprised what you can do with epoxy. Alright, I'm going to continue on this and I'll start the camera up again when I've reevaluated. Okay, so with this internal component, with this power supply circuit board in place, there is a lot of room down there. I mean, not a ton, but it's going to be close. Basically, I'm looking at these solder joints and the wires and how far they're sticking down and how it lines up with the top of the case, and it's close. It's not too bad. It's not the greatest either. There's actually posts down here. There's little, I guess these are probably the mounts for the old power supply. It's a little lip, a little jutting out from this post on these. And I could put it on top of those or in front of them. Probably on top so that the solder joints aren't sitting directly, just to keep them from being right up against the plastic. you know, you don't want to rest the weight of this thing on the solder joints. That's not good practice. Yeah. So does it matter which way I have this? Not really. Except, you know what? Because this post here widens, I'll gain just the slightest bit of extra clearance because we have a bevel here. I don't know. I'll just go with that. I don't know. It probably is not enough to affect anything. But yeah, now I'm liking the idea of removing the wings and sticking the black piece, the black lip on the outside. Looking at it next to the switch, you know, it won't look that bad. It won't look that out of place, is more like what I mean. Okay, so cut, evaluate, cut, evaluate. I'm going to cut this wing off right here. In fact, I can do that on camera. It's only going to take me a minute. Always use safety glasses. And other safety equipment as required. One thing about the rotary tool is it's not super precise, so you want to undercut things and then sand them the rest of the way. That's not quite there, but it's close enough for testing. See, now we're getting closer. So you just take a baby step at a time when you're designing something like this. Okay, so here we have the end result. Well, actually, wait a minute. I need to do one more thing. Cut this other ear off. That looks okay. Alright, so I have glued a piece of plastic to both sides. This one has to be relatively narrow to fit in between this post and the outside shell. So I slid this in. I think in this case I put some glue on the actual connector, and then I slid it in and then took a piece of plastic and got it in there until it was dry. This side was a bit more difficult. I think what I did was I had this out halfway. Again, I applied glue. I think I applied glue to the piece of this piece of plastic first, and then I slid it in halfway and got the stick in there, and then quickly, because this is super glue, quickly brought this down and took a narrow tool. I had a small file. I just made sure that it was butted up against the case, and then let that dry, and there you go. It's captive, it's removable, and it fits. There's a little piece of plastic on here that comes down, you know, and I just kept on filing and cutting the bottom until I got to the point where this closes all the way, and that's not going anywhere. Sorry if it's a little out of focus. All right, anyway, so the next thing I need to think about is this piece, this part, the main circuit board, switch, power supply, and I think what I'm going to do, I'm going to be careful here, but this doesn't fit in here straight, it's at an angle. I'm not really interested too much in getting it straight. It actually fits just like this into the case. I can put the lid on, but it's a little wobbly. So I'm going to start by putting a couple of notches in the bottom of these posts. I don't want to make them very big, I just want to make them big enough to hold this board in place. And then on this end of things, I'm going to have to work out some way to secure this end. That would be good too. Maybe if I get those notches just deep enough, I can put some matching notches on the top of these so that I can kind of snap it in, because these should have just a little bit of flexibility to them. Ooh, not much. Be good if I could just get it in there like that. I don't know. Let me cut some notches in here and see where that gets me. Of course, I'm going to do it very little at a time. Just going to make a small cut here. And a small cut here. Again, this is, you know, trial and error, taking our time. How tight is this right now? It's pretty freaking tight. I'm just going to make these things a little bit deeper. Deeper I make them, the better it'll hold it in there. Ooh, that's a nice lip there. I'm liking that lip. Yeah, I think that's just about all I'm going to do with that. It would take a nice hard hit. And with the screws in there, I imagine these posts aren't going to move around as much. I don't know, I think I like it. Alright, so now I'm going to take care of soldering this connector onto this board. Let me think about how I'm going to do it off camera and then come back and with the solution. My memory card was full. Okay, so I've got the neutral and the load's hooked up to the switch. Everything's on these connectors now. The only thing left . Yeah. So, note to self. Forget about this thing. It's only in the way. We don't need it. It's worn out its welcome. Goodbye. Now everything fits nice and easy. So we've got AC/N on this side, AC/L on that side. So neutral. The neutral conductor is there. Okay, here's one of my famous documents. I like to combine all of the information on one piece of paper, and I do like to use pieces of paper, hard copies, rather than try to look at it on a tablet or a phone. That I guess I can put this down here like this. Can't really see the reading on there too well on camera, can you? That's better. Alright, so okay, there we go. And power on. No light. There's no light on this thing, right? Okay. Minus 12 is minus 11.92. Plus 5. It's 5.5. Second plus 5, 505. And this one is 1210. Nice. Let's just see. Instant off there, huh? Yeah, boys and girls, I think we're ready to proceed with the other side of the power supply, the low voltage DC side. Okie dokie. That's convenient. The voltages are marked on here. I don't know if this is going to be a consistent color code, but in this case I'm going to write it down. Why not? Don't forget to unplug that. So we've got white is labeled minus 12, And brown is plus 12. And that's really small writing. And I kind of don't trust my eyes, just gotta make sure. Minus 12 is white. Plus 12 is brown. Red is plus 5. Ground is black. Black, not to be confused with blue. And one, two, three, four. Just wondering if there's a separate shield connection. But no, there's only 4 conductors. Okay. Oh, yellow. Yellow is shield. And just as a matter of course, it is directly connected to mains ground. Into the trash you go. Which means that the yellow has got to make its way over to here. And I wish I knew that that needed to be... I don't really know if I'd have wanted that one on that connector anyway. Alright, anyway, so let's... Do we fit? Do we fit? We still fit? Okay, we do. Alright. Okay, looking pretty good. I'll go this way with it so it just sort of stays out of the way. All right, getting it in here. I've made it so secure that yeah, right, okay. Easy there, nice and easy. And that is that. Okay, I've decided to redo this. Putting the mains on this side of the board is not as good of an idea as running it through from the top. So I'm going to do it this way. Just make sure you can see it. So I removed this connector. I just grabbed one side with pliers and desoldered and yanked it out, and then the other side went back and forth a couple times, but it wasn't too bad. So and I of course desoldered my existing connections. So this is actually filmed after I connected the low voltage, so I'll probably put it there. We'll see. Anyway, yes, this is a much better way to do this. Much better. Oops, that's still hot. Okay. Get it in there a little farther. There we go. And cut the rest of that off. Back to this. Okay, so we have to be careful. You know, on one of these or some of these, I'm thinking I'd want a little light on there. What do you think? A little power indicator on top. Super easy to do. There we go. 5 and -12 and +12 and shield. I'm sticking my multimeter probe into an outlet here in the ground part of an outlet, trying to get a shield continuity. Yeah. You know, that pin says shield, but it's not. That's not shield. Shield is the outside. I think that pin might be another, might be connected to, well, let's see what it is. Why not? Let's make our books accurate here. Unpluggy. Probably another ground. testing for its continuity on anything else here. There's no connection. I don't know if they're supposed to be, but that ain't the shield. That's what I'm thinking. Comment on this video if you know differently, but I'm thinking this is NC for now. And yellow, the shield is here, the actual shield. This is not connected. Use a Sharpie. Not connected. Shield, like that. Okay. Next thing to do is test it on an Amiga. Okay, so here we have my upgraded power supply plugged into an Amiga 500. See the power LED from here. I'll just flip it on. It's got a GoTech. Check my other videos for how I made this faux floppy disk for my GoTech. Everything seems fine. Okay, there's a workbench loaded. Let's try a game. Okay, no problems at all. No sound at all either. I don't have anything hooked up. I'm horrible at this game.